Hallo, mein Name ist Christoph Körner und heute spreche ich über D3, Data-Driven Documents und heute über Visualizations. About me, I am a master's student in Vienna University of Technology. I study visual computing. I'm also a CTO of a company called GSIM. I wrote the book about data visualizations with D3 and Angular. It's pretty cool if you can combine these two techniques and make some D3 directives. It's very cool. Also, I'm a contributor of the N3 line chart library, which is also combining Angular and D3. It's also very cool. I will show you a little bit later. And I'm the organizer of the Vienna Kaggle meetup, where we do some machine learning. Also pretty cool, I think. You can find me on social media, and I have a blog, so you can take a look. All the slides are online. Here, there's a URL if you want to give a look now or later. You will find all the things in the slides. So what we will speak about today is like D3. Actually, the first question is why we use D3, or why. What are the benefits of D3 compared to like Canvas or WebGL, for example? The second important thing is like how does it work? Like what is data-driven? What is data join? What are these D3 specific things? And then I will show some demos and examples. Okay, this is from the D3 website. D3 is a library for manipulating documents based on data. It helps you to bring your data to life with using HTML, SVG, and CSS. Okay, I think that's actually already pretty good. So it's a DOM transformation library, so a JavaScript library for DOM transformations, especially, and you can use it for HTML and SVG, like out of the box. That's a little bit cooler than jQuery, for example. You can use it with data, so you can create data-driven visualizations, and we will see what does this mean exactly. So why do we use D3, or why do we prefer D3 over a different library? That's an important question for the beginning. And I think the question is more, are we using SVG, Canvas, or WebGL? I think that's more the important question, because once we decided to use SVG, we should use D3 because it's the best for this case. So the question is more like which image rendering technology is the best for our purpose. So actually, if we are using SVG, we have a lot of benefits. So one is, for example, like lossless scaling, because we are always dealing with vector graphics that can like adapt to the screen resolution and always display it perfectly and rendered perfectly. Also, we can use CSS and CSS for styling. So we have a technology that we already know, and we can like listen for we can put event listeners, like JavaScript event listeners, on certain objects in the graphic itself, which is also pretty nice, actually. So again, a technology, JavaScript, that we already know, and we can use it together with SVG. That's pretty cool, actually. So there are some differences between SVG and Canvas when it comes to performance. For example, SVG is very good when you're dealing with not too much elements, let's say. This is also very like vague, this sentence. And when you want a lossless scaling, so it's very important that you have like a responsive design, or that it looks always very good. And like Canvas, for example, which is a pixel graphic, is much better when you deal with a lot of elements, that are different, because you can optimize SVG when you have similar elements. And when you have like a fixed resolution. So the performance of Canvas is very good when your resolution is not too high. When you have very big resolution, then you have very big pixel graphic that you have to redraw every frame. That's quite expensive. And then WebGL is hardware accelerated graphics. So it's a little bit something different. So it's more for like rendering 3D physical effects or something like this. This you can do in WebGL very nicely, and you have all the shader stages and so on. And this is somehow a different field, but it also renders to a raster graphic, a pixel graphic in the end, so it's like similar to Canvas. Okay, so now we decided, okay, SVG is cool for our visualization, because we want to have a responsive visualization. So the main advantages of D3 are lossless scaling, debugging, and performance, where lossless scaling is due to vector graphics. We already discussed this. I will skip over this. The second thing actually is very, very important when it comes to graphics, which is debugging. I don't know how many of you have already experience with OpenGL or WebGL or something like this. And try to find some bug or try to debug a little bit, it's very, very, very annoying. And the fact that in SVG you can just open the developer tools, look into your graphics, see the nodes. I mean, here I selected the head of this figure. I can see how is the transformation of the head. I can like rotate it, everything. I can. The debugging here is super, super good. That's a big plus for SVG. If you have ever used Canvas, then you open the developer tools, you click on the thing, and you see a Canvas box. So and you see nothing inside. So this, personally, I like this a lot. And then it's performance. Here it's meant performance in the sense of like D3 compared to other libraries that deal with SVG. And here D3 is very nice because it uses technologies like SVG and JavaScript directly, and it doesn't have a wrapper around it, but it uses them directly. So your performance is bound by the browser and not by the framework. So that's also pretty cool. So how does data-driven visualization work, or how we use D3? So the main object in D3 are selections. That's very similar to jQuery actually. So you make a D3 select and D3 select all, and you can select, like have a query selector, and you select elements in the DOM. So then you have a selection object which has specific functions that you can use to manipulate them. That's again very similar to jQuery. You have like append, you have text, you have again select, attribute, and remove. So you can do like the basic manipulation that you would expect from a DOM transformation library. Again, very, very similar to jQuery. So what is the main difference actually? Well, the D3 stands for data-driven documents. So now we might ask, what is data-driven actually? And data-driven is a technique where we want to replace loops to draw elements explicitly. We want to change these loops, and we want to have the data being responsible for where the element goes, but we don't want a loop in the end. So we want to just have this line saying SVG append circle for all our data, and then just say where should it go, but we don't want a loop around it. And I will show I will show this in the next slide, actually. So here we're looping over 5 values, and then we're drawing like a circle every loop. So that makes like 5 circles with a different, oh, that's very weird. That should be like X here, CX, with an X attribute. So we can modify this a little bit, use an array. This D3 range gives you an array from 0 to 4. And you can use the for each loop to iterate over this loop. And then you can do exactly the same. Actually, here is correct, is CX. So you draw again 5 circles, but you again have to explicitly loop over all these circles. What we want is that we define how the graphic should look, and then we just put the data, and it generates it out of the data. And we don't want to loop over all the elements and yeah, actually we don't want the loops. We want to have it like implicitly defined. And actually, this is how it works in D3. So it's actually very similar to the previous example, but you see that we don't have this for each loop anymore. We just have something here which says data, which makes some kind of data binding from the data array to the selection. So it binds the selection to the data to the selection, and this I will explain in the next slide. And then we can append the circle for every element, actually. It means this. And then we have this line here, which is a concept called dynamic properties. So where did the loop go, actually? The loop went in these dynamic properties. So we put this array we bind this data array to the selection, and then we define dynamically which properties the elements should have. And that's a little bit this data-driven approach in D3. There is now here something saying enter, and it looks a little bit complicated actually to understand. And this is actually another cool feature which makes D3 super, super cool and awesome and very unique and very different from jQuery actually, which is a concept called data join. So we're not just binding an array to a selection, but we're joining an array to a selection. So what does it mean? It just means actually that we are computing out of the data and the selection, we are computing 3 sets. The enter set, the update set, and the exit set. And actually, this is very easy. all the data points that are not in the selection are in the enter set. All the data points that are already in the selection, so for every element in the data set where there is already an HTML node, we have an update, like it's in the update set. And for every element that is not in the data set, that we removed, for example, from the data set, but there is still an element in the selection, we have an exit set. So we have this data join between the data set and the selection, which gives us these three sets. And this is a very, very important concept. Actually, this is the main concept in D3. Also, like the most, for the most of the people, the most difficult to understand when they deal with D3, but once you have this, it's very easy, I promise. And then, so how do you create this data join? It's very simple. Again, we saw this already. You just call data. So, and then you have also you can have a key function which identifies the elements for the join, but this is not so important. Important is this data function. So you call data on a selection, and you give an data set to this data function. This creates the data join, and then you have actually three. Then you can access these three sets, and there is this enter method. So the join.enter gives you the enter set. The join on its own gives you the update set, and this is where it is a little bit complicated because actually there should be an update function that gives you the update set, but there is none. So this looks a little bit weird. And the .exit function gives you this exit set. So you can access these three sets by calling enter nothing or exit. And there's a little twist again inside. Usually if you have a data set and you have an empty selection, then all your elements are in the enter set. So you want to add these elements to the screen. So let's say you have like an array with 5 elements and you want to try 5 circles. So you select an empty selection of circles. Then you say all elements in the enter set, please append the circle to the selection. And when you call this enter set, when you use this enter set, it automatically adds all the elements from the enter set to the update set. So from this step here to here, internally it moves all the data points to the update set once you call the enter set. So, and once you have this, actually you can go and you can create, for example, transitions, which is very easy also in D3. And the transition is simply an animation between two states, actually. So 2 states of attributes, these are all SVG elements. So you define like some circles, for example, you give it some radius and some x value, and then you just call transition, and then you define another attribute, and it will create, in this case, a linear transition from the first state to the second state with a duration of 250 milliseconds, and you can define the delay, the easing, and the duration of the animation also, but basically it gives you some default animation here. So very easy making transitions is just like putting this transition method in between and then putting another like attribute function, for example. It makes automatic interpolation of the attributes. Very, very cool. Yeah, I can show a quick example of how this transition looks like. This is from the website of Michael Bostock. So here you see that, I mean, this is like, you just have like a transition and then you have another like shape of the curve, and then it just changes automatically. So it's like very little code. All these code examples I will show you are probably, most of them are under 100 lines of code or so. So it's very, very cool. Okay, so they then have easing functions. Like there's also an example on easing. So if you don't know what is like cubic easing or so, you can check this out actually. Another important thing why D3 is so cool for visualizations is a concept that is called scales. Scales means actually the mapping from a certain domain of data to a certain range. And this is very important actually when you think about access in a data set, or even you think about the chart and you want to put some data inside the chart, then you always need to map the points to a certain range of pixels. So this is very important. Or also when you want to create some visualization that scales, for example, that is responsive or so, then you also need to scale like always to a certain pixel range, and you can do this with this scale. Another thing why D3 is very cool it has a built-in generators for standard SVG elements. Like common elements that you're often using in visualizations, especially data visualizations. And one of these generators, for example, is a so-called axis generator. So what does it do? I mean, you just create a scale. Here in the top, you see how you create the scale. It's very simple, actually. You say you want the linear scale from a domain. This is like the range in the data, like the extent in the data set. And then you say to which pixel range you want to map it. And then you just say you want to create some axis, and then you put the scale. Yeah, and then you just, like, there's some call function, then you just call this generator on the selection. It will give you an axis. So it's simple like this. D3 is all like this. So you have generators, and you plug elements together, and it's like always a few lines of code to create stuff. Then there are like more... there are other generators, for example, a LineGenerator. I don't know who of you has already tried to make an SVG path element and to put the D attribute inside. Yeah, there you have like control points of Bezier curves, so it's getting also a little bit tricky. But you know, with this LineGenerator, it's super, super nice. You just say you just give your data points, and then you define the line, and you say the X and Y values. How should it extract the data points from your data set? And then you can call this again, very similar to the example before, on a path element. Actually, on the D attribute, you can plug in this generator, and it will generate this D attribute on its own, which will result, for example, in a normal curve, like a concatenation of the points, or you can even have like smooth curves, or there are lots of options to connect these points. Then there are error generators, which is the same with another Y value. And then is another cool thing. They have like complete layouts that you can create. So very, very common tools that you use in data visualization. There are already layouts for this. So it's again very simple. You just define your data structure, and you just create a layout. You can configure it with a couple of options, and then you can just print it. This looks like this. Well, there is a little bit more code, but it's not a lot actually. The best address is actually the GitHub page of the project. It's amazing, and it has lots of cool examples. So yeah, very, very simple things are like that you can do with it are like bubble charts or like bar charts, for example. And then there are more complicated layouts like the chord layouts, but you have also integrated some cool GeoJSON features like topological maps and stuff like this. I will show you, like, there's also something baked in which makes collision detection for all your SVG objects that you're using. So, so this is very neat actually, and it has almost like, it has really very little code. There is like some draft of a mobile application. Well, this is all SVG, by the way, and this using also material design. And I mean, this line is just, you make a line generator and you put it with a scale on the screen, and that's it actually. So it's very simple actually. And then if you want to have a transition, you just put the transition element, and you put like you update the line, the D attribute of the line, and then you can have a transition of this. It's all automatically. I mean, you can get into, like, you can customize this. You have tween functions and so on, so you can do crazy things with this. Let me see if it loads. This is very cool actually. So they're mapping like the here you have like a topological like data from this from the world, like the path from this world map, and they map it on a sphere, and then you can also rotate this sphere, and then they connect these points. Well, where they have like this, well, they trick a little bit with these lines, but it's still very nice actually. So, and then some stuff I was working on actually. So where I used D3 first is, it was a program called MoreSpaceOffice. It's like an office simulation for big office buildings. And what you can see here is this is one floor from a building with 5 floors, and it has like 2,000 workplaces and a couple of people in the building, and we animated the people in the building with different colors that correspond to different categories. And this was all built in D3. This is all SVG, the floor plan, so you can scale, you can go have this, and then you can make it bigger. That's very nice. Well, this is a very simple bar chart, but I mean, these charts, they show the capabilities of D3 very well, but actually you can customize them, like you can customize like the shit out of them. So it's really, really cool. So here we have like labels, and we have like zooming and dragging, and yeah, and the code for this is actually very clean. So you can just go inside and you can actually make your own chart type because you just make another generator or you can even draw the representation on your own, and then you plug it inside and it works. So that's very cool. So, well, this I draw Yoshi from graphics. I draw him in Inkscape. I put this SVG into a website, and then I use D3 to just take the different elements of Yoshi, and then so I animated him. So I moved his feet, and when he jumps, I moved his legs, and when he jumps, he makes the feet like this, and I'm not sure if he uses his arms also. And he needs to jump over the ball, and when the ball hits him, so this is simple like box collision detection, then it's counting, it's taking a life from you. So, but this was very easy. I mean, this like took maybe like 5 hours or 4 hours to create. So you can imagine that you can build some quite powerful stuff, cool stuff with this. All right, thank you for your attention, and I'm happy to answer all your questions.
How does the integration with Angular looks like? How complicated is it?
It's not too complicated, actually. Just you have to, for directives, you have to define a custom. You have to create the element yourself, actually, because the namespacing of the SVG element. But apart from this, this is the only thing that you need to be careful about. And then it turned out that I always like try to separate a lot between D3 and Angular, and use the D3 event system, which is very, very cool also. Mm-hmm. And then to propagate events from the visualization to Angular, and then to bind these values with two-way data binding, for example. Okay. So, but once you have this setup, and you can use the setup from the project and 3 line charts, once you have like this little setup structure, it works like charm, actually. It's very cool. Please.
What sort of input data does it eat? So can you just throw JSON at it, or?
A good question, yeah. I didn't say this. Yeah, basically you take an array. What you want in the end is an array with objects. So that you saw these functions like function di, where you returned an element. So there you can actually, you use this for mapping. So you can have like, once you have an array, you can have anything inside and you can map it back, actually. So that's quite cool. And what is also cool with D3, a lot of people use it for data processing, actually, because it has cool built-in features for grouping of data and so on. So it's really, really great.
But it reads out of the box CSV, JSON, and all those stuff, right? It can read out of the box.
Yes, sure, yeah.
JSON and all I mean, stuff, so you don't need to do anything.
It also has like, it has a cool function that can load delimiter separated data, so any delimiter. And you just say which delimiter and where the data is, and it just loads this data and puts it inside your data set.
I would have another question.
Okay.
What's your experience with the performance on different devices and different browsers with, I mean, that's an SVG question rather than a D3 question.
Yeah, that's it.
What's your experience? Because, for example, your floor plan looked like you had a lot of SVG objects.
Yeah, this was quite the limit, actually. So if I would do it again, I might have done this with Canvas, I must say, because there were like almost 2,000 of these people moving around in the building, and the actually biggest thing was that the floor plan was like an SVG with 50 megabytes or something like this, so quite big. And this 5 times, I think, like for the floor plan, or 4 times.
With minified SVG, or minified SVG doesn't help you probably because of D3 not being able to.
Yeah, I had the process like it was like a very tricky part, the processing of this, because there is something that you can remove, but then again, if you remove a transformation matrix from a group, for example, like then everything is screwed. So you need to be very careful with this. But yeah, like once it comes to like really like points that move around and that are not super similar, I would say, it's much better with Canvas maybe. But if you want, like, we wanted also zooming inside the plan, and that is, you have this out of the box with SVG. That's the great thing. And yeah, I think it depends on your setup. But yeah, this was the limit of performance, definitely. Yeah.
It's not hardware accelerated SVG.
No.
And they're planning to do it, or?
Oh, I don't know actually. It's not running on the GPU. That's it. But I mean, the thing is, like, the question is what from these computations they can put on the GPU, because I mean there are loads, but there are not too many. I mean, it's not that they have like lots of vertices and they're applying shaders or so. So it's a little bit tricky. Okay.
Cool.
Thanks a lot.